There's an Nvidia H100 GPU in orbit right now, running Gemini AI. A startup called Starcloud put it there. That's not a plan that's already done. SpaceX filed for a 1 million satellite constellation for orbital data centers, and Google's Project Suncatcher wants 81 satellites with TPUs, flying less than 200 meters apart, like a swarm in low Earth orbit. Here's the twist. SpaceX filed for a $1.75 trillion IPO, and in those IPO documents, their lawyers wrote something telling. Orbital data centers may not be commercially viable. The company that wants to build this thing, they're not sure it makes money. So what's the actual debate? 3 forces are pulling in different directions. Let's look at each one. First, the technology. Starcloud proved it works. H100 in space, running real AI. Google tested their Trillium TPU in a proton beam. It survived 3 times the radiation it'd face in a 5-year mission. The hardware side is further along than most people realize. Second, the economics. This is the hard part. Launching on Falcon 9 costs about $3,000 per kilogram. At that price, orbital data centers make no financial sense at all. But Starship changes everything. If SpaceX achieves full reusability, launch costs could drop to $200 per kilogram. Google's analysis says at that price, a space data center costs about the same as a ground one per kilowatt per year. The problem? Starship's not there yet, and SpaceX's SEC filings explicitly say the orbital data center business carries significant commercial risk. Third, energy. This might be the real reason it happens. Ground data centers already use 4% of all U.S. electricity. One facility can pull 100 megawatts. That's a small nuclear power plant just for one building. AI training demand is exploding. Every new model needs more compute, more power, and space changes that equation. Solar panels in the right orbit are 8 times more efficient than on Earth. Near continuous sunlight, no cloudy days, no land use fights. Starcloud's CEO says it directly. We're very quickly running up on constraints on where you can build new energy projects terrestrially. Cost isn't the only question anymore. It's whether we can physically build enough ground data centers. So where does this leave us? 3 things to watch. 1. Starship reusability at scale, that's the cost, game changer. 2. Google and Planet's test launch in early 2027, the first real proof of concept. 3. The SpaceX IPO this June, how investors value this bet. Orbital data centers aren't science fiction anymore. They might not work economically, but the forces pushing them forward are all real and accelerating. AI demand, energy limits, falling launch costs. The question isn't if we can. It's whether we need to. If this got you thinking, follow for more on the future of AI infrastructure. See you in the next one.